Greetings, it's Maxo Diddly here, and today I am going to be showing you how you can mass resize a bunch of images using Python. So let's get right into it. So firstly, make sure you import OS and then do from pil import image. I'll show you how to import the pillow library at the end of the tutorial, but we're going to be needing these two for this tutorial. So we're going to do two variables. We're going to do input underscore dir equals input, and we're going to do output underscore dir equals output. So we've got two variables. One's going to be where the images that we want to resize are going to be, and the other one is going to be the folder where we want to output all of our resized images. So now we're going to create our resize function. So we're going to do def resize underscore image, image underscore path, output underscore folder, and a factor. So this starts the definition of a function. We're going to call it resize image, and then we've got three arguments. Image path, the location of the image to resize, output folder, where the resized image should be saved, and factor, how much should it be resized. Now, we can increase or decrease sizes by factors, and we might have a factor of 1.2 or maybe 0.8. And then we've got this lovely bit of code, but don't worry, we're going to break it down. We're going to do try. And this begins a try block. The code inside the block is attempted, and if any errors occur, the errors are caught, and then we execute the code in the exception block of code as opposed to crashing the program. In our exception, we're just going to print the error message. That includes the path of the image that caused the error and the error message, so we know what's going on. But back to the try. So we're going to do with image.open image underscore path as img. So this line opens the image file at the location specified by image path and uses it as an img. And this is going to be the image that we're going to be resizing. Then we're going to do new underscore size equals int img.size 0 star factor. Star means multiply, by the way, or asterisk I should say. Int img.size1 multiplied by the factor. So this calculates the new size for the image. It multiplies each dimension of the image, the width and the height, by the resize factor and rounds it to an integer, because you can't have decimal dimensions. You know, you can't have something that's 5.5 pixels wide. That's just not how it works. And img.size.0 is the width, and this is the height. And then we're going to do img equals img.resize new size image anti-alias. So this resizes the images to the new size using the anti-alias filter. A filter that reduces the distortion artifacts known as aliasing when an image is resized. You can customize this. There are other options you can do, like for instance if you're doing pixel art you might go for the nearest neighbour approach. I'll do a separate tutorial on pixel art. However, we're just going to stick with anti-alias for the purpose of this tutorial. And this line just resizes it. Then we're going to do output underscore path equals os.path.join, output underscore folder, os.path.basename, image path. So this line constructs the path where the resized image is going to be saved. It's the output folder joined with the base name of the original image, and then after we do img.save output path, and this is going to save our resized image to the output path. So we're going to do def create underscore output underscore directory path, and then we do if not os.path.exists path, os.makeDirs path. And this function is just responsible for creating a new directory for resized images if they don't exist already. And then we're going to make another function. We're going to do def get output directory, input directory as the parameter, then we do relative path equals os.path.relPath, input directory and input dir, and then we do return os.path.join output dir relative path. And this function is going to just generate the path for the output directory that corresponds to the given input directory. Its purpose is to preserve the directory structure of the input directory in the output directory. So if you've got an image in a folder, the output folder will have a folder with the same name, with the same images inside. Now, let's go back to the main method. basically. So we're going to do 4 subdirs files in os.walk input dir. So, this begins a loop that goes through every directory and file in the input folder and its subfolders. Then inside we're going to do for file in files. And this begins a nested loop that goes through every file in the current directory. Then we're going to do if file.endswith.png. We're going to check if the current file ends with a PNG image. Potentially, the reason why we're doing this is, let's say you're using a Unity project, you're going to have a bunch of meta files that you're not going to want to touch. Now, you can obviously change this to check if it ends with PNG, JPEG, GIF, whatever, but we're going to stick to PNGs to keep it super simple. After that, we're going to do input_file path equals os.path.join subdir and file. So this is going to construct the full path to the file. Then we're going to do output directory equals get output_directory subdir. So this gets the output directory corresponding to the current input directory to preserve the folder structure. We're using the function we created just before doing this main method. Then we're going to do create output_directory output directory. And this creates the output directory if it doesn't already exist. And then we're going to do output_file_path equals os.path.join output directory and file. So this is going to construct the full path to where the output file will be saved. Then we're going to do if not os.path.exists output file_path to check if the output file already exists. We're then going to call our resize image function. We're going to do resize_image input_file_path output_directory and then the scale factor we want to do. We're going to do 1.2 to make the image a little bit bigger, but you can make it a little bit smaller or keep it the same size if you just want to waste electricity. So doing it by 1.2 will make the image 120% of its original file size. Doing 0.8 would make it 80% of its original file size. And that's basically it, but there's a little thing you need to do. So if you're in Visual Studio, you can right click on your Python environment, which will be located up here. You can then go to Manage Python Packages, type in pillow, and then click here or click Run Command pip install pillow because you need the pillow library for this to work. If you're not in Visual Studio, you need to do your pip install pillow somewhere else, maybe in your command prompt or wherever you have your Pythons installed. But with all that, we're going to firstly then also right click on our project and then go to Open Folder in File Explorer. And we're going to look at our Python project. So this is going to be the structure. We've got a couple of cool images here. Then we got a couple more cute dogs and, well, one dog and a bear. And yeah, so we're going to save our work. We're going to hit the play button. Make sure your images aren't open when you do this. No errors occurred, so we can hit enter. So we go back to our subfolder. We go to here. There's an output folder now. Let's open it up. Oh, look. The subdirectory was maintained, and if you look at the file paths, like the file sizes here, they are bigger than before. But let's just check the dog. So we want to right click, go on to properties, go to details. Cool, 644 and 960. If we look at it again, as you can see, we did increase the size. So, thanks for being a great audience. Be sure to leave a like and a comment if you enjoyed, and subscribe for more Python tutorials. Thanks for watching.